UCSD 111 Lecture 3 Set 3, Logic with Memories. Assume the task at hand is to implement the following Boolean logic expression in a memory array. Now, the different bits I'm just writing here. Here, we're implementing an XOR and OR of these two variables and an AND of these two variables. And if we come here to a just truth table of this, we can just write it with respect to the possible logical elements of A0, A1, and write the Boolean logic table as you've learned in your logic design course. Now, if I have a memory array, what happens is that remember we had the address line, so the address in this particular case will be 2 bits, A0, A1, and then depending on the values, we have 1, 1, 1, 0, 0, 1, and 0, 0. We have the possible logic functions that we've computed here, and this what that means is that every time we have that, what we are going to do is we're just going to show a dot notation of this value. So here the first one, which is a data 2, data 1, data 0, and then we basically just translate this to the dot notation here. So what we did in effect here is we translated a truth table to a logic memory array, and this is how we use the memory array to implement the logic here for us. Here's another small example of the same thing. If we have x, which is a function ab, basically we have the AND of a and b, y is the OR, and z is the subtraction, which is a and not b. And if we do this logic and we look into the dot notation, we would get the truth table translated into this logic function, which we can implement using the logic array we just had. So any memory array, using the same principle, any memory array can be used for implementing logic. This is a notion which is in real life called a lookup table. Basically, we had a logical truth table, and we translated that logical truth table into the dot notation of the memory, which was really that bit line and word line that we were encoding, and this is a lookup table logic as it is typically called. There are two kinds of devices that are using this notion of a logic array. The first type is a programmable logic array, which is an AND array followed by OR array, and this is only useful for combinational logic. This has fixed internal connection. As you probably have seen before, any Boolean logic can be right in terms of the clauses of AND and OR, and this is a very old construct. The PLAs were popular in 70s, where people use that to implement any Boolean logic. Field programmable gate arrays are basically arrays of logic elements that can define both combinational sequential logic, and the internal connections between the blocks that are programmable are also programmable. So we could actually connect various parts of the chip with this programmability. Let's just take a look into the structure of a PLA here. We are just having the output X as a and OR clauses with AND first and OR. So we have the AND array first. We put the inputs through the AND array, and depending on whether A or A bar or B bar or C bar is selected, we are going to represent the logic on these lines, and then we are just going to follow that with an OR array. You probably have seen this in your logic design course before. The dot notation will be straightforward. Every time we are using A or A bar and B or B bar connection, we are just going to put these dot notations, and then the OR array is saying where are we connecting these. Now, let's go to the next set where we talk about how the programmable logic is getting implemented.